Hello, geometry students. Welcome back to our final video on trigonometry, where today we try to apply trigonometry to story problems, what we might call real-life situations, and use our facts and knowledge about the trig ratios to help us solve. Before we do that, though, I've got one warm-up problem based on finding missing angles. So if you would pause the video here and try to find theta, or angle A. If we are trying to find this angle A, step one is to figure out what relationship we have. 11.9 is the opposite side. 10 is the adjacent side. The trig function that works with opposite and adjacent is going to be tangent. So tangent of our theta of some angle equals the opposite over the hypotenuse. And now we can fill in at least the opposite and the hypotenuse. We are still looking for the angle measure. So this is going to stay as theta, where the opposite side is 11.9, the hypotenuse. Wow. Opposite over adjacent. Opposite over adjacent. TOA, Mr. Goodacre, TOA. 11.9 over 10. Opposite over adjacent. And if we want to solve and get theta by itself, that means we're taking the tan inverse of both sides. And so we need to figure out the tan inverse of 11.9 divided by 10. This is where we will round. This is more acceptable here. We don't have square roots. So the tan inverse, let's go to Desmos. Again, I got to go to function. The tan inverse, go back to main, of 11.9 over 10. And we'll close that parenthesis just to make sure. And we've got roughly 49.958. So we'll just say that it is about 50 degrees. It's right around 50 degrees. And so again, the key here, though, is to use the tan inverse, that we're using that inverse function. So now as we get to trigonometry and story problems, you're going to see a couple of phrases that will come into play. One of them is called the angle of elevation. The other one is called the angle of depression. Angle of elevation is if you're looking up, angle of depression is looking down, but there's a key, right? It's always in relationship to this horizontal line of sight, right? So if you are standing down looking at something, you're looking down from your horizontal down is an angle measure. Whereas if you're standing looking straight ahead and all of a sudden you see that plane, you look up. That's called the elevation. What we do need to be careful of, though, is that the angle of depression often has a common error, right? If this person is standing up here on top of a building looking down at the house, their angle of depression is not 78 degrees. They are looking down at 12 degrees. Their horizontal line sight down to here is 12 degrees. We can fill that 78 in because your horizontal line sight down to the ground creates a perpendicular. Okay, so we do have to be careful with angle of depression, and I do have an example of that. First, here's a different one. When a plane takes off, it is 2,025 meters from the base, that's the bottom, the base of a 400-meter tall cliff. If the pilot wants to clear the cliff by 50 meters, what must his angle of elevation be? So again, here's my, here's our plane. And, you have my permission to make fun of my drawing. It's completely fine. I am just a regular old math teacher. The cliff that it's trying to avoid is over here. Okay, we know that this cliff is 400 meters tall, but the pilot also wants to make sure it goes 50 meters above that. It wants to clear it. The plane itself, we are told, is 2,025 meters away. All right, so here would be our right angle. It wants to know at what angle must I take, right? At what angle must we start our ascent up into the air so that we clear the cliff by 50 feet. So in a sense, we have a triangle that looks like such. The right angle is where the cliff meets this horizontal distance, right? The plane is 2,025 meters away. It wants to not only clear the 400-meter cliff, but also 40 feet above it. So the triangle that we are looking for would be 450 meters tall. And we are looking for this angle right here, right? This angle of ascent. Therefore, what two sides of the triangle do we have? Well, once again, we have opposite and adjacent. We have the opposite and adjacent, and if you've been working along with SOHCAHTOA, you would hopefully now know that that's the tangent of our angle theta has to be opposite over adjacent, and we'll fill that in so that we can solve. So tangent of whatever angle measure we are looking for is equal to the opposite, which is 450 over 2025. Again, when we're looking for an angle measure, we're going to have to take the tan inverse of that opposite side. So we're really looking for the tan inverse of 450 divided by 2025. The tan inverse. So let's go back over here to decimals. The tan inverse, I still have that in there, of 450 divided by 2025. Let me just make sure we grab those numbers. 450, 2025. So our angle measure is going to have to be 12.5 degrees. Our angle measure is going to have to be 12.5 degrees. And so it's going to be extremely helpful if you can draw yourself some pictures to model what's happening. And remember, we're really just trying to get a triangle out of the picture to help us. Example 2. How wide is the Tomorrow River? How wide is this Tomorrow River? Well, the width of the river is represented by this side of the triangle. So we're going to label that X. They are telling me that from this point of the river over here to this point, we have an angle of 35 degrees. So that's the angle we are working with. Therefore, we have an opposite side labeled 20 meters and an adjacent side of X. What uses opposite and adjacent? Once again, this is tangent. And you'll notice for some reason, a lot of story problems use tangent. Just how it works out. So tangent of some angle is the opposite over adjacent. And let's fill in what we have. The tangent of the angle. Well, we know the angle now is 35. Equals the opposite side, which is 20, over the adjacent, which is X. All right, we're finding a missing side. When we did this the other day, we said we would multiply both sides by X, which means the X ends up over here on the top right, and then we have to divide by tan 35. So essentially, these two elements just switch spots. Or X equals 20 over the tangent of 35. 20 over the tangent of 35. So 20 over the tangent of 35 gives us a measurement of 28.6. X would equal 28.6, in this case, meters. That's our measurement. So the width of the river would be 28.6. And again, this is just relating back to what we've done the last couple of days in terms of using these trig ratios to help us find missing pieces. All right, here's our last example. Vernon is on the top deck of a cruise ship. All right, so here's this big old cruise ship, and he's way up here on the top deck. He observes some sort of a dolphin down here, Oh, this is not going to be good. I can't really draw a dolphin, but we'll try. Oh, that's pretty close. All right, he sees this dolphin down here swimming away from the ship. Right, the ship is going that way. The dolphin is going to the right. Vernon's position, okay, if he's standing here, is 154 meters above sea level. All right, so if this is the water, he's 154 meters above the water. And the angle of depression, he's looking down here at the dolphin, 35 degrees. Find the distance that the dolphin is to the base. How far is this line, the dolphin to the base? Now, we've got to be careful with this angle of depression. Remember, if you're standing up here and all of a sudden you decide to look out, you look out at this straight line. That's called your horizontal. When you look down, that's the angle of depression, which is 35 degrees. Which means the angle we need to use, which is right here, would be not 65, but 55. It'd have to total 90. Okay, the angle of depression is on the outside of the triangle, meaning the angle of depression plus the inside angle have to equal 90. And now you're going to see that we would have this picture. 55 degrees here, 154 and x. Now we got to figure out if that's the angle that we're using. Up here is 55. X is the opposite side. 154 is the adjacent side. And what uses opposite and adjacent? It is tangent. So tangent of our angle measure equals the opposite over the adjacent. Now we fill in what we know. The tangent of our angle measure, which is 55, equals the opposite side, which is x, over the adjacent side, which is 154. 154 is on the bottom. We multiply both sides by that number. Therefore, 154 times the tangent of 55 is equal to x. That'll tell us how far away the dolphin is from the boat. And we can type that into decimals. 154 times the tangent of 55, or 219.9. 219.9 meters away from the ship. Okay, but the key for angle of depression is to realize that that measurement they give you represents the distance in between the horizontal and the triangle, and you need to use its complementary to get the angle inside our triangle. If you have any questions, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.